Right. So we are going to do regression analysis using Excel. So we are going to do regression analysis using Excel. Okay. So under this we have three major um, and using analysis tool pack analysis tool pack. Okay. The second one it's by using that is by using graphical that is linear uh, graphical representation will be now using inbuild using inbuild. The third one will be using inbuild excel functions, okay, to calculate our that is to calculate our coefficients. Okay, so I'm going to start with the first one, that is the graphical representation, because it's the simplest one. Okay, it is the simplest one. So I'm going to use that is to use it. Okay, so remember our model here. I think which is used to track that is a monthly rainfall in comparison to um, uh, during our descriptive statistics we did some of that is a summary analysis of this data, where we calculated the correlation and also covariance, and we saw that we had a high correlation between these two variables. That is, okay. Remember that when we were doing the descriptive statistics, we found that we had a very high correlation. Okay, like for example, let we can redo the correlation. Um, correl- correlation. Okay, so remember we said that that is equal to cor, and we said for correlation that is it doesn't matter if we are dealing with population data or sample data. Okay, so correlation can calculate either that is a correlation of between two variables of in a sample data or in a population data. Sorry. um Secondly, now we need the second what? We need the second variable. That is now the y variable. Okay. Then with that you just close and it will calculate what? The correlation. And you can see we have a very high correlation. Okay. Correlation of 0.95. Okay, meaning that is one variable explains 95% about the other variable, so they have very high correlation. Okay, yes. So basically, and we said correlation basically shows us the relationship between what? Between, it shows us the relationship between two variables. Good. So I want us to first use the graphical representation. That is as our first what? As our first method of doing regression analysis. So under regression analysis, we need basically what we are creating. We are creating a model which we can use to predict. That is a predictive model. So our target here is to find the coefficients. Okay, that's our objective here, to find the what? The coefficients, the two coefficients, because for our case this will be an example of simple linear regression because we are only dealing with two variables. Okay, yeah, so we want to find our model, and our model will have that is the coefficient. So we can do a draft of the model. So our model will be that is equal to umbrella. We have umbrella cells, umbrella cells, okay, will be equal to now, that is a constant. Let me say, let me call it, yeah, can just write constant, constant variable, okay, then plus or minus, that is plus or minus what? Plus or minus plus or minus our constant, that is our y-intercept, y-intercept model. Okay, so this is our model. So we can now start with the linear graphical representation. We'll get the value or we'll get the equation of our straight line, okay, or the model. Okay, so by doing so, we'll just go to that is the data. You can highlight the data if you want. Yeah, of course, we have to. That is, you highlight the data, then go to insert. Okay, go to insert, then go to recommended charts, or you can go to all charts. Then we need what? A scatter plot, so that we may see how our that is our data points are distributed. Okay, so we go to scatter plot, and for our case we will need this one. Okay, like this linear scatter plot. Okay, we don't need this because okay, first of all let me just choose this and see what you will see. So basically this shows us the what? The trend. Okay, that is the distribution of our what? The monthly distribution of our rainfall, and this could be better if we were to represent that using a line chart. Okay, it could be better if we were to do that using a line chart. Okay, so if we okay, just a minute. So I want this line chart. Okay, so with this you can see now the rainfall trend. Okay, and also that is the rainfall trend, the one with the blue, and also the umbrella cells, that is, which is this one. Like for example, at the peak of or the month which we receive that is the highest amount of rainfall, you can see it is the same month which we have the highest sales. Okay, in of umbrella. Okay, yes, and you can see the trend. It has almost the same trend. Why? Because where we have a dip and where we have a peak, you can see it's the same thing. Okay, yes, so you can see like whenever the amount of rainfall is going down, you can see also the umbrella cells is going down. When they maybe the amount of rainfall increases, also that is increases, also the umbrella cells increases. So you can see that. That's why we said we have a positive correlation, a very strong positive correlation. Anyway, that wasn't our objective. Our objective is to check that is how our data is what is linearly it is linear distributed. So go to recommendation once again. You can come to just recommended charts, but what if maybe you don't see this one, okay, on your side? So the best thing is to go to all charts, then go to scatter plot, and then choose the umbrella cells, this one with the linear relationship. Okay, so you can see at this point where we are having the maximum cells and also the maximum amount of rainfall. This so on our x-axis, this is the amount of rainfall, umbrella cells. We have the umbrella cells. So you can see at this point of maximum rainfall amount, it's the same point we're having what? The maximum cell of umbrellas. Okay. Yeah. So you can see that that is the trend. Okay. The rainfall, and also we did not receive for the 2 years, we did not receive rainfall amount which was that is rainfall which was less than 80 millimeters. That is from our what? From our that is from our plot. Okay. Yes. Another assumption. So before we can even continue, what is the possible if we were to to make or to include the equation that is the straight line, or to plot that is a straight line, okay, what would be the value of our what would be the value of our y-intercept? Would it be a positive value or a negative value? Just think about as I receive that is this call. Just think about this. Okay, what is the what will be that is will we get a positive or a negative y-intercept in this case? Who can tell? Hello, George. Okay. Yes, Joroge.
I think it's to be negative.
Why?
If you look at the distribution, not let's say the distribution. Don't know. If
Yes,
you
it's okay.
extrapolate,
Mm-hmm.
if you draw a line and extrapolate from beyond the x-axis, it falls down on the negative side to the y-intercept, which is negative.
Okay, yeah, that's point. Yes, Matthias.
I think it's. I agree with Njoroge that the Y
Yeah,
intercept will be negative.
yeah, very correct. Because you can see if we that is make yeah, that is line of best fit, it will and extrapolate it. It will first of all pass through the x-axis, and if it passes through the x-axis, then very correct. So we can now, even before we can continue, we know that is our y-intercept will be a negative value. Okay, good. Now after that, now we want to make what? To make that equation of straight line. Okay, we want to make the equation of straight line. So, and of course, under graph, you can always do some formatting. Choose which format maybe you see it okay with you. Okay, you can always choose that is the format which will nice you, and also the color. You can always change the color. Okay, can always change the color of your data points depending with your what, depending with your preference. Okay, okay, then after that we want now to do what, to make that is like a linear uh, thread line. Okay, or we want to make a line of best fit. Okay, so to do so, just click on the plus sign here, then go to thread. Okay, when you go to thread, just don't click thread yet. Okay, you can see we have a certain arrow here. Okay, meaning there is more. Okay, it means there is more of that. Okay, you can see even here. Okay, you can see even here, can see even here, can see even here we have more. Okay, meaning if for example you want to keep your that is your legends, you can do what, you can keep them where you want. Okay, for that is the error terms, you can also, yeah, do the same. Then the data points, you can decide where to put the data points. Okay, okay, and then for the chart title, you can what, you can have more options of where to position that. Okay, yes, okay, good. Now let's go to trade line. So under trade line, of course, we need what, it's either a linear or exponential or linear forecast. Okay, but for our case it's more of forecast, but we can go still go to more options. If you click more options, you will see all these options. Okay, and for our case we need what, we need a linear relationship, and then under the linear relationship we want to include the to set the intercept. So I'll just click here to set an intercept, or that is if you want to set your intercept. Okay, it's all about upon you to set. Okay, but for our case I don't want to set that is I don't want to set the intercept, but I will need what, I will need to display the equation of the straight line. Okay, you can see this is the equation of the straight line. I will okay, just a minute. Okay, just let me go back. So I want more options. Then I will need equation of that is straight line, and display also the r squared. Now in this case, r squared is what? R squared is the it is used to remember yesterday we said that r squared is used to measure the goodness of it, or the performance of it. Okay, so that is in under symbol linear regression or coefficient of multiple determination. That is when we are talking about multiple regression. Yes, Kevin.
Yes, good evening.
Good evening to you,
Yes,
Kevin.
at times you seem to be breaking. I don't know if it's a problem on my end.
Okay.
Yeah,
Uh,
I,
when
I,
did
lo-
I break?
I lost you at the trade line. Yes,
Okay, I can repeat that.
yes, thank you.
Okay. So let me undo that. I can just do the whole thing. So we go to go to that is charts. Okay, what a scatter plot. So under scatter plot, of course, we will see which will tries to give us that is the linear relationship. So we'll select that one. Okay. Then now we want to make or to include the trend line or the linear um, that is what can I call, that is the line of best fit. We have to include the that is the line of best fit. So you'll go to that is this hard sign, then go to trade line. Under trade line you can go to more options, and when you go to more options you will see this part. Okay, we need what we need, of course, a linear relationship. Okay, and under the linear relationship, okay, we also need to display our equation, and also that is the r squared, whereby in this case I have said that is the r squared is what, the r squared, it's the coefficient of determination, or it shows us the goodness of it. And you can see the value of that is the value of our r squared. It's already good, you can see, because in terms of performance we have accuracy of 95%. That's good. But if we would get anything less than, let's say, 80, then we it would mean we have to recheck on our parameters or our variables, or choose another model. Another model, it means we are using what, we are using other features. So any thing maybe, let's say, above 65, that is 95%, or it's fairly good. For anything above 90, it's fairly good. Anything above 95%, it's what, it's okay. It's the same as the confidence level. When we are doing that is the statistical analysis of that is if we get that is the confidence level, that is level of 95%, then we can conclude that is our that is our our model. Okay, it's kind of statistical significant. Okay, for medical experiment, we usually use confidence that is level of 99%, because we don't have any confidence level which is above 99% or of 100%. Okay, so for medical, we have 99%. Of course, we have 1% for that is for doubt. Then for that is the common research work, it should be above 95%. Okay. Anyway, let's continue. That was just by the way. So at the end, you can see we have what we have. the equation of this line or the model. Yes, if you can always also do some formattings to change also the, that is if you want it to be either to be this way, this dashed, or you may decide to a continuous type. So to choose a continuous type, you'll just come to this part. When you click the dash type, you can what? You can choose maybe this continuous line. Okay. So you can see we will have what? We'll have a continuous line, not dashed. Then you can do what you can use. Okay, good. Now we have our model. Can see our model. Okay, so meaning that why it's our umbrella cells. Okay, our constant here now will be this coefficient, which is coefficient of x variable, that is 0.4482. Okay, so this is what, this is the coefficient of x variable. Then we have our y-intercept. You can see as we had projected that it will be what? It will be a negative value. So you can see now we have what? We have the negative value. Okay. Yes. So now, is it possible if we can use our model to maybe to do some projections? Yes, let's try. So I'm just going to use like x, this variable. Okay, I'm just going to use our x 15 or anything close to what? Close to 15. Yes, Bill, we can't you. Maybe you're speaking on mute. Okay.
Okay, good evening.
Yes, good evening.
I'm requesting. I just want to inquire about something here. I've been about the dependent and independent.
Yes.
So, like in this scatter plot that we've drawn, when we're coming up with the scatter plot, along the x-axis and then the y-axis, there's no labeling.
Okay, yes, it's just because I did not include. Okay, that is the axis. You are talking about the axis.
Yes.
So to do the axis, you just need to come to this plus sign. Then you can do what? You can include the axis. Okay, you can include the axis. Then under the axis, now you can rename. Of course, you can see this area we have what, this will be our rainfall, because we don't have any value of cells which is above what, which is above even let's say 100. Okay, so our x, and remember our x is what, it's rainfall. So here it is rainfall amount, it is our rainfall amount. Okay, and this it's what, this is our umbrella cells, umbrella cells. Okay? And from even the data points, you can know which point is to which point. Okay, or which axis. Yeah. So, like for example, if I click, let's say, if I click this or bring my cursor to this point, so you can see the point we have, the that is the umbrella sold at what, rainfall amount of what, of that is 165.4. And you can see now the coordinates here, you can see the coordinates here. I don't know if I can show you, but down the statement you can see the coordinates, that is 165.4, meaning that's our what, axis. And remember our that is our float data. The floats, we had some floats on what, on floats are basically decimals, so we add some decimals that is on the rainfall, that is amount, and then for umbrella cells, we add our number. Okay, so you can see at the maximum amount of rainfall, and also maximum coordinates. You can see the coordinates there. So with that, it is an evident that rainfall amount, and our y-axis is what is umbrella cells. I hope we are good, Bill.
Yes, I'm good, but I think I want just I think a recommendation.
Uh-huh.
So it means that when plotting the scatter plot,
Mm-hmm.
it is the Excel that will come up with the data points, the axis.
Yes, of course, it will come up with the axis. And again, even before it can come up with the axis for you, okay,
Yes, yes.
you know, what are we using to predict the other?
We are
We,
using the rainfall to predict
uh-huh.
the number of umbrellas that are sold.
So X automatically becomes our independent variable.
Mhm.
Yes. So in case maybe you are trying to draw that is a graph which maybe brings another kind of axis, then you are what? You can even change on your side. Okay. You can choose or try to see which plot, because it will definitely come with what? With suggestions. It will be now for you to that is to that is your objective. Yes. Okay, I think we are now good.
Yes,
Okay,
yes.
okay, that's okay. So I want us to try to use this model, and I'm just going to do it mathematically, okay, and see if we are going to get what? A point which is close to this, either less or greater than this. And we can say it is plus, the error term is plus or minus 3, or plus or minus, that is minus 5. But 5, it's big. Okay. Anyway, let's try and check what value we'll get. So we are going to say, now you can see this is our model. We want to predict what? We want to predict for y, which is umbrella cells, using what? X as our 82. So what here we don't have, it is X and Y. But Y, we can get Y if we know what? If we know X. And X is the amount of rainfall. Okay, let's try and see. So equal to that would be our constant. So you can say into brackets is 0.4482, okay, multiply by our x variable. What is our x variable? For now we need 82. You can either set the cell, or you can manually that is type 82. Okay, then close that, and then we will minus our what? We will minus our, that is our intercept, because we know it is plus or minus, and in this case it is minus, so which is will be minus 18.914. Okay, and with that we'll get what? You can see we got almost 18, okay, or 17. So with this, at least you can see it is something close to 15, okay, or it lies between 15, that is a amount of rainfall, which is 82 and 83. Okay, So with that, we can try what? We can try to predict the amount of rainfall for the what? That is the amount of umbrella cells given the amount of what? Given the amount of rainfall. We can always create that is a formula here, which will give us that is such uh, trend. Like for example, let's try here, and then I'll come here and insert that formula, that is 0 point sorry 0.44 we had 0.4482 0.4482 multiplied by the value of this cell. Okay, then we minus by what? Then we minus by 18.915 and then run. So we can even drag here. So in case maybe we want to predict the amount of rainfall for this, okay, we want to predict the umbrella cells, okay, for the following year or for the following 6 months, given the amount of rainfall, it is possible. Why? Because you'll just need to maybe insert the values of that is rainfall you are assuming you will get. Okay, if you paste them, you can see what you can see. We are getting then that is the number of umbrellas, and this, of course, you will have to round it off. Okay, so with this, you can see you can do what you can do a prediction given the value of rainfall. You can know maybe possible amount of that is umbrellas which you will sell, and it is easy to get what it is easy for us to get that is the amount of rainfall, because we usually have almost the same what we usually have almost the same pattern, okay, of the rainfall. So with that, you can now predict the umbrella cells and be able to know um, in this specific date I will need this amount of rainfall. That is amount of umbrella cells maybe in your stock. Okay, so it will help you to make that is item restocking decisions. Okay, yes, so that's our first step. All that's our first method which you can use to create this model or to create this equation, predictive equation, or maybe predictive model, just to say. And you can see from that is the r squared, which is used to that is to show the goodness of it of our line and also performance of our model. So you can see our model it's fairly good because it fits 91% of our what of our data points. Yes, any question before I can go to the second method? Any question before I can go to the second method? Okay, if no question, go to the second now, using analysis toolpack. Okay, I want us now to use the analysis toolpack. So for analysis toolpack, we are going now to use the data analysis toolpack, which we added on our Excel. Remember us adding this tool. Okay. So under now this data analysis tool, we are going to do what? We are going to now perform the regression. Can see under it we have very many that is analysis, uh, starting from the ANOVA of single factor ANOVA of two factor with replication. You can also do correlation and covariance. I think we did this. We also did this, and we also did descriptive statistics using this analysis toolpack. Okay, so today we are going to do regression analysis using this tool, that is using this tool. So to do so, just click on the regression. Then once you click the regression, you can see you can see the prompt window. It is requesting us to enter the y range, whereby it is our y variable, and then input also the input also to input x range, and under x range now we are going to put the x variable. Then we are told to choose the what, the confidence, that is the confidence level. All right, so I want to do so. So let's start with the inputting the y range. So for the y range, we have all these. So you are going to select the y range. Okay. Then the x range. Now you are going to input x values. Okay. Then after that, we want this output to be maybe in a new sheet. I can put it on a new sheet. You can also decide to put it on the same sheet if at all you don't have that is a lot of the of content in the same sheet. Okay, so for my case, I'll go for new sheet, and what do I need? I don't want the residuals, don't want the residual plots, don't want to, that is the line plots, the line fit plots. If at all you want, it's okay. You can just check all this. Okay, but for me, I just need the output. Yes, George.
Oh, I wanted to ask on inputting the Y range. If should we highlight all the values in Y range, or we just choose a single mark?
We have to choose all the values, because you can see under the range I've taken from E26. So you have to input all the values of the wire, that is of the y. Okay.
Okay, thank you.
Okay, good. Then now I want what? I want my output. I'll just click OK. Once you click OK, it will give you such an output. Okay. It will give you such an output. Now under this output, now it's where now we have to start what? Now we will have to start our interpretation. Okay. And with that, I'm going to start with the summary output. For today, I will cover the summary output. Then tomorrow, I will explain more of what? More of the ANOVA, that is ANOVA part, and then continue with the next summary output, or the regression statistics part. Good. So let's start with the multiple what? Multiple R. From our calculations in the previous, that is here previously, what do you think multiple R is? What do you think multiple R is? You can just cross check this value. Let me just enlarge this. This is our multiple R, and here we have our data. You can see, you can check out if you can see that the same value across that range. So of course that value is this one. Okay, and it's what? Our correlation. So multiple R here basically is what? Is our, basically is our correlation. Okay, it is our correlation. All right. What about the R square? You can see the R square here, or the coefficient of determination. Let me just enlarge my graph. You can see we have in the same value here. That is the R squared value here. It is the same as this value, which is the coefficient of determination, or basically it is showing us what? It is showing us that is the goodness, okay, or fit of our line, okay. Yes, and then we have the adjusted R used when we are dealing with what? With multiple linear regression. Then we have the data that is the standard error, okay, or the vertical deviation. So you can see the minimum, it is very small value. If already it's a small value, we know that our model is what? It's a good model, okay. Then observation is the count of our data entries. All right, let me share maybe some notes. That is a presentation. Yeah, these are notes which I prepared, and that is a writing regression analysis output. So it has a uh, sorry,
Mwalimu, I think we
sorry,
lost you.
yeah, it my network buffered. So where did you lost me?
I think when you just began to explain the notes,
And
as you were explaining the notes, when you just
I can't
opened.
hear you. Yes, sorry.
Can you hear me now?
Yes, I can hear you.
Yeah, when you just opened the notes is when we lost you.
Okay, so I was saying that under the notes, I've prepared these notes and I also shared with you via email. Basically showing you all those that steps we've done. Okay, okay, or the linear regression equation, and now I also have this is the
Excuse Mwalimu, I think we've lost you again.
okay. Let me connect. That is use another network. Sorry for that. Just a minute. Okay, I think now it must be sorted. Okay, now I'm clear, right?
Yes, you are. Yes,
Okay,
you are.
good. Okay, good. So I was showing that I've done a summary of all the processes in that is a very basic way, and that is for all the what for all the methods. So uh, we are here. I've already done that is for the analysis toolbox. That is the regression analysis using Excel analysis toolpack. I've also illustrated all the steps which I've done here. Okay, even the step of adding that is the data analysis tool. Okay, and then also all the what all that process. I've shown you. Okay, now we are here. That is interpreting the analysis output. So for the analysis output, we have the summary output, which I have shown you here. This is the summary that is output. And then we have the ANOVA part. Okay. Yes. So we have and I think I have even that is given a summary of what is this, and we've said it's what this. We've said this is correlation. This is our correlation. This is our correlation. This is the coefficient of determination. Okay, or it measures the performance of our model. Also, this we said we usually use this when we are dealing with multiple data. Okay, then we have the standard error, and we've said the smaller the standard error, the more accurate or the more good is our what is our model. And then we said we have the observations, and observations we've said that is basically it's the count of our data entry. So let's try and see the notes what they are saying. Then for multiple, R we've said is the correlation coefficient, and it measures the strength of the linear relationship between what between the two variables. So you can see the value of what of our multiple R of our coefficient, that is correlation coefficient. Can see it's a big point, that is a big value. Okay, 0.95, meaning we have a strong, okay, we have a strong relationship. So we've said it is used to measure the strength of the linear relationship between two variables. So the correlation coefficient can be between what, or must be between -1 and 1, and it's an absolute value. Okay, which indicates the relationship strength. So the larger the absolute value, the stronger the relationship. And we are saying that one means we have a strong positive relationship. Then -1 means we have a strong negative relationship. And then 0 means we have no relationship at all. Then we have also R squared, which I said it is used to measure the performance of our model. And it is called the coefficient of determination, which is used to indicate of fit, if our model fits well our data. Okay, so it shows how many points fall on the regression line, or how many points fall along what along the regression line. Okay, yes, and we are saying that R squared value can be is calculated from the total square sum of squares. More precisely, it is the sum of square deviation of the original data from what? From the mean. I think we calculated this and we said R squared is given by what? We had some that is here. Though it's a formula, you can go and recheck on that. Okay, so we have that is it's the sum of square data. So we are taking the actual minus that is the mean. Okay, that is this is the actual points minus the mean. Then you have to what? It is squared. Okay, and also summation. Then of course we'll have now to divide with n. That is the total number, or that is either n or small n. Okay, so in our example, our R squared is what? 0.91, which is fairly good, or which is fairly good. And it basically means that 91% of our values fit the regression analysis model. or 91% of our data is along what? Is along the regression line. Okay. In other words, 91% of our dependent variable, that is y variables, are explained by the independent variable, that is the x values. Generally, r squared of 95% or more is considered to be a good fit. That's why we are saying that this is a fairly good fit. It doesn't mean it's bad, but for a strong, that is goodness of fit, it's 95% and above. Then we have the r adjusted r squared, and we've said this is the r square adjusted for the what? For the number of independent variable in the model. And it's mostly used when we are dealing with multiple regression analysis. That is, you will want to use this value instead of r squared for multiple regression analysis. That is, when your model takes into consideration more than what? More than one independent variable. Then we have the standard error. And we had said that standard error, it's also another goodness of fit measure. Okay. And you can see it is another goodness of fit measure that shows the precision of what? Of your regression line analysis. So the smaller the number, the more certain you can be about your regression equation, or it shows the reliability of your model. So while r squared represents the percentage of the dependent variable, that is the standard error, it's an absolute measure that shows the average, that is distance, that the data points fall from the what? Fall from the regression line. I think I had done that. I had illustrated that. So of course we have some points here which fall that is just of the regression line. Now the distance between these points and the regression line, it's now what we are calling what? The standard error. And the smaller the standard error, okay, the more your model, it's what? It's good. Okay. That's why we are saying it's another test for goodness of fit. Then we have observations. Okay. So under observations, we've said it is simply the number of observations in your model. Okay, good. Now under the ANOVA, that is part, we are going to discuss now this tomorrow, where we will talk about that is the degrees of freedom. Okay. Remember, even in chi-square, that is chi-square, we usually have degrees of freedom as what? N minus what? N minus 1. That is the degrees of freedom. Okay. But it sometimes varies with what? With the model. So, or with the distribution. So we also have some conclusions, and we'll see how we can say that is conclude that is between what? The sum of squared, the total sum of squared, in comparison to what? To the residual. Okay. Yes. And then we'll also talk about significance f. Okay. That is, if our f statistics is less than 5% or less than 0.05, we will always say that our what? Our model, it's a statistical significant, or it is statistically significant. If it is statistically significant, then we can say that is our model, it's statistically reliable, or it is depth, that is tomorrow. And then also from tomorrow we will use now the that is okay, think we discussed that. We'll also now use what? We'll also now use that is the regression analysis formulas, inbuilt functions in Excel to calculate what? To calculate the intercept, and also to calculate what? The slope. Yes. Any question? Any question before we end the class? Any question? Yes, George.
Okay, may you kindly explain again the meaning of adjusted R square?
So I was saying that that is for the adjusted R square. For this case, we don't need to. That is to study more about it. Yes, yes, Geoffrey. Oh, okay, George. Sorry. Right. So for adjusted R squared, now it is majorly applied, or it's majorly used what when we are dealing with the multiple that is regression. But maybe tomorrow I will give you that is an in-depth reason as to why we use it, that is under adjusted R squared, compared to what, or compared to when using it that is in simple linear regression. All right. All right.
Okay.
Yes. So I think we are done with today's class, unless someone has a question. Okay, if not, uh, evening and a lovely night. Let's meet tomorrow.